Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and the topic of the day is what the heck does Interstate 95 have to do with our weather? So it would probably be appropriate to say the road to an explanation starts here. At least I hope it does. All right, so here are some things to consider. I-95 does not control the weather. If you thought that it did, then we need to eliminate that from your thought process. I don't really think anybody did, but just in case. Number 2, North Carolina is one of only 3 states with a warm ocean current offshore having reasonable proximity to a mountain barrier. The other 2 states are South Carolina and Georgia. Of course, the warm ocean current is the Gulf Stream, and the mountains are the Appalachian Mountains. The orientation of the mountains and the coastline create boundaries that are in large part oriented from southwest to northeast. During the winter season, shallow cold air gets trapped east of the mountains. We call this CAD, or cold air damming, and there can be an awful lot of temperature contrast that can exist from our coastal areas, especially our southern coastal areas, on up to the mountains. In fact, I've seen differences as big as 30 degrees just across the viewing area that I used to serve when I was on television. So it can be a pretty dramatic effect. And the shallow cold air is most entrenched closest to the mountains and is increasingly modified as you get closer to the coast. And it sort of makes sense that the Gulf Stream is sort of a heat source. Even in January, the water temperatures in the Gulf Stream can be 70 degrees. And so any wind that blows from that direction is obviously going to have a big impact on eastern North Carolina, where the mountains, in terms of their cooling effect of trapping this shallow cold air, that effect is going to be most pronounced closest to the mountains, and in between is where all the problems begin to crop up. So here are some more things to consider from a graphical standpoint. Here are the mountains, which are oriented basically southwest to northeast. Here's the Gulf Stream, oriented southwest to northeast. And again, the coldest air is going to be just east of the mountains and then will progressively get milder until you get toward the coast where it can actually get quite warm. And here's Interstate 95, not exactly parallel to that boundary that I've shown there between the blue and the red, but pretty darn close. And so it ends up being a pretty reasonable way or reference point to talk about boundaries in the wintertime between precipitation type. Now, not all events are the same. The weather system itself is going to have a lot to say about exactly where these boundaries set up. But there are times when I-95 is a good reference point for maybe the transition between rain and ice or rain and snow, depending on what the situation may be. Okay, now, and as I just mentioned, this is just a graphical way to reinforce this idea. This boundary can be all over the place. It could be in extreme eastern North Carolina. It could be much, much closer to the mountains, or it could actually be somewhere in the middle. And I do remember, I'm going to go into a bit more detail here, there was one Friday night in January, I believe it was the first week in January, and it was the 11 o'clock news, and the temperature at the RDU airport was 61, and the temperature at Burlington was 33. Now, as the crow flies, those two places aren't that far apart. And so the influence of the ocean got all the way into the triangle area, which it doesn't always do, but sometimes it does. And then as soon as that effect stops, then it gets much, much colder as you head farther and farther to the north and west. And last but not least, elevation also plays a role because the lines of equal elevation above sea level, for the most part, are also oriented from southwest to northeast. In fact, this boundary here separates the coast and the coastal plain, if you will, from the eastern Piedmont and the Sandhills, okay? And the boundary between the coastal plain and the Piedmont is pretty darn close to I-95. And then you have the boundary between the Piedmont and the foothills, and then you have the boundary between the foothills and the mountains. And again, all of those boundaries are oriented southwest to northeast. So just from an elevation standpoint, if the air is coming in from the southeast, say, it's going to gradually rise and get cooler as you head farther and farther inland and get higher and higher above sea level. So all of these factors come into play to create boundaries in North Carolina separating different types of weather or different temperature regimes and precipitation types. And all those boundaries are many, many times oriented from southwest to northeast. Again, the weather system does have an impact on this. So if the boundary is initially setting up east-west, and that's the dominant part of the system, then these lines will be oriented east-west, okay? But in many, 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 many situations, it ends up being exactly something like I just showed you here. All right, that is bonus weather video number 2. I hope that clears up the I-95 corridor debate. I will have your regular daily weather update coming up later this afternoon, and the next bonus weather video will be next Tuesday. And again, I thank you from the bottom of my heart for all of your suggestions. They have all been logged, and I am going to try to address them one by one as we head through the next several weeks. One of the suggestions was about some of the major forecast busts that I can remember, and the biggest one that comes to mind is the 20-inch snow in January of 2000. There was actually a missing upper air report in Georgia, and as a result of that, the models did not initialize the atmosphere correctly, and it ended up having a huge effect on the output forecast for that particular event. And so instead of just getting a couple of inches of snow, we ended up with the biggest 24-hour snow in history. So I'm going to be trying to gather old data from that so that I can actually show you from a graphical standpoint what that entire scenario looked like. All right, that's it for now. You all have a great weekend, and we'll talk to you again later this afternoon and again next Monday. Take care.